Right. So yesterday we discussed about the importance of thermodynamics. Right. So the main importance of thermodynamics is energy changes during physical process or chemical process. Right. So whatever is either physical process is carried out or chemical process is carried out, how the energy changes will be taking place, and also efficiency of heat engine. So that will be when heat is transferred to work, what is the efficiency. Then attainment of equilibrium, how the equilibrium is attainment between the processes, and the feasibility of the reaction. Then the spontaneous nature of the reaction, or that becomes process. Right. So these are the major importance of the thermodynamics, and somehow limitations also we have discussed. Right. What are those limitations? It is applicable for macro particles only, large particles. Right. So then the rate of reaction cannot be predicted. Rate of the reaction cannot be predicted from thermodynamics. Then mechanism also cannot be predicted. Right. So then it cannot be applicable for microparticles like protons, neutrons and electrons. Right. So this is the somehow importance and limitations of thermodynamics. So we have to understand the importance of the thermodynamics. So we have to know about some basic terminology which is involved in thermodynamics. With the help of that basic terminology, so we are able to enter into our topic. Right. So put heading basic terminology. Basic terminology. So what is the basic terminology involved in that? That we have to understand with the help of simple diagram only. Right. So this is the entire board is there. Right. Digital board is there. Out of this I am going to select only some amount of portion only. Right. So this is amount of portion which is under our observation or study. Right. Any specified portion which is under our observation, that is considered as system in thermodynamics. Right. So this is the word system. System means any specific portion which is under our observation or study. Right. So the remaining part of this board is what? Surroundings. Right. So clearly understand the subject. Right. The remaining part of the board is surroundings. Right. Right. The area which divides system and surroundings. This is the area which divides system and surroundings, that is known as boundary surface. That is known as boundary surface. Right. If we add system plus surroundings, right, that is equals to what? Entire board. Right. In this case, if in the universe we have to consider any one part that is under our observation, the rest of the remaining part of universe is called surroundings. The system plus surroundings, which is equals to what? Universe. The system plus surroundings is called universe. As we said that, so take hot water in a open beaker and kept it on the bench, how the heat will be transferred to the environment. Right. So the heat will be automatically transferred to the environment. Right. So that water in a beaker is our system. We are going to observe that. Right. So the remaining atmosphere will be surroundings only. Right. So system plus surroundings, that becomes universe. Right. So this is, so means what are the terminology involved in this? So three terms will be there. So the first one will be system, second one will be surroundings, Then third one will be boundary surface. Boundary surface. Three terms are there. We have to understand these three terms clearly. With the help of this, the entire thermodynamics will be based on the system only. Whatever is the system, we have to consider, right? So that part will be under our observation or study, right? So put first one heading system and write the definition. Any specified portion, any specified portion which is under our observation, any specified portion which is under our observation or study is called a system. Any specified portion which is under our observation or study is called system, right? So next heading, surroundings. The remaining part of the universe, except system, the remaining part of the universe is called surroundings, right? The remaining part of the universe except system is called surroundings, right? Next heading, boundary surface. Right. The area which divides system and surroundings. The area which divides system and surroundings is called boundary surface. The area which divides system and surroundings is called boundary surface, right? For example, right, so entire building will be there. So our class is the system. System. The remaining area of this building is what? Surroundings. System plus surroundings becomes overall building, right? So system plus surroundings, right? So here system and surroundings are divided with what? Walls, right? So this wall is known as what? Boundary surface. If our country is the system, India is the system, the other countries are surroundings. System plus surroundings, our country and remaining countries becomes universe, right? So like that, whatever is that is under our observation, that is called system, right? So these boundary surfaces may be fixed boundary surface or movable. Boundary surface may be fixed or movable, right? So means in some cases it will be fixed, right? In terms of our classroom, the wall is a fixed one, right? So it cannot be moved, right? So if this curtain will be keep here, so this is the one room and this is the one room. Just we have to imagine, right? So means that becomes movable only. Curtain we have to move, so from one place to another place, right? So here put one curtain in between these two benches, right? Two portions will be there. So that is the word movable one, right? So system, boundary surface may be fixed and movable, right? So or in some other cases, boundary surface may be real boundary surface or rigid boundary surface and imaginary boundary surface. Right? Means in some cases it may be real or rigid, right? In some cases we have to imagine, right? How we have to imagine means, consider a cylinder with weightless frictionless piston. We don't want to see the piston, but we have to assume there is a piston will be there, right? So consideration of weightless frictionless piston, which is applicable in a cylinder containing gas. So then the gas will be moving either upside or downside, that is depending on the forces applied on that gas. So therefore we have to get that is a imaginary boundary surface, right? Boundary surface may be fixed or movable, or boundary surface may be real or rigid or imaginary. So then one more will be there, boundary surface will be diathermic wall, diathermic wall or adiabatic wall. Diathermic wall or adiabatic wall. So what is meant by diathermic and adiabatic? Adiabatic won't transfer heat through it. Whatever is the wall is there, that won't allow heat through it, right? So diathermic means it can allow, right? It can allow heat from one to another, right? So one will be, heat will be transferred between the boundary surface, or there is no transfer of heat between the boundary surface, right? Between the system and surroundings with the help of boundary surface. So based on that, how many type of boundary surfaces will be there? Like so three kinds of boundary surfaces will be there. Here we have to remember about diathermic wall and adiabatic wall, right? So in adiabatic wall, no heat transfer, no heat transfer, right? So in diathermic wall, transfer of heat will be takes place, transfer of heat will be takes place, right? So consider one boundary surface, whether that can allows heat or does not allows heat, right? Based on that, so the boundary surface may be two types, right? So therefore finally overall draw this diagram. What is the system, what is the surroundings, and what is the system plus surroundings, right? Just draw the diagram and write that equation. System means any specified portion, right? This is the box will be there. In this box I have selected only this portion which is under our observation, that is called system. The rest of the box is called surroundings. So then the area which divides system and surroundings is known as boundary surface, right? System plus surroundings is equals to universe. System plus surroundings is equals to universe, right? As we know that what is a system? System means any specified portion which is under our observation. Based on that how many type of systems are available, right? Write down types of systems. Right. How many types of systems are available? Three types. What are those? Open system, closed system, isolated system, right? So just I'll give with the help of simple notations and diagrams all the type of systems, right? So what about that first one? Open system. Right, don't write, just listen. Open system, closed system, because we have to understand this each and every terminology. So with the help of this only we have to move in further depth level, right? So without understanding this all, we cannot understand the further levels, right? The third one will be isolated system, right? One will be open system, closed system, and isolated system, right? So we will go with example, right? With the help of example we have to understand that systems, right? These all the types of systems are based on boundary surface based on boundary surface and transfer of heat and transfer of matter, right? So based on the transfer of heat and transfer of matter, with the help of heat and matter, so we have to discuss about three type of systems, right? So first one is the open system, right? So consider in open system hot water in a open beaker, hot water in a open beaker, right? Directly we have to consider hot water, or take water and provide flame to water, that becomes boil, right? When it will be reaches to the 100 degree centigrade, that becomes vaporize, right? So once we stop the providing of temperature to this water, so water is boils at 100 degree centigrade. So if we stop that heating, right, so we have to wait for some time. What will happen? That water temperature will be transferred to the surroundings and it will be reaches to the atmospheric temperature, and its temperature will be decreases, right? So means the change of heat will be takes place or not? Yes, there is a change of heat energy. And what about matter? How much water we have taken? The same amount of water is there or not? No, little bit amount of water will be what? Vaporizes, right? So because of hot nature, some amount of water will be vaporizes. Therefore matter will be changed. So therefore how we have to define that open system means the system in which both heat energy and matter will exchange with its surroundings. Will exchange with its surroundings. What is meant by delta Q means? Delta Q means, delta means change, right? Delta means change, Q means heat, that becomes Q2 minus Q1, or else if we have to write final minus initial, right? So this we have to write Q final minus Q initial, right? Is there a difference in heat energy or not? As there is a difference, therefore this final minus initial value is not equals to 0. So that's why delta Q is not equals to 0, right? At the same time, some amount of matter will be there, right? Initially some 10 liters will be there. After that little bit 9.75 liters we observed that after evaporation. So therefore there is a change in matter also will be there. Therefore delta M is not equals to 0. What is meant by delta M? That is M of final minus M of initial. This is also not equals to 0. So such systems are known as what? Open systems, right? So during this season, right, we able to put heaters, right? So we have to use heaters. So once you have to put water and heat for up to certain temperature. So unfortunately you forget about that, and you may went outside and you come back and see what will be observed. Entire water will be evaporates due to continuation providing of heat energy, right? If you know that to switch it off, right, and you may go back, go to outside and come back and see, right? So initially hot water will be there, but after some time it becomes cooled, right? So where the temperature will be moved? From system to surroundings, right? So because of open system, right? So simply take hot water in a beaker and kept it on the bench, and after few hours what do you observe means the heat will be exchanged with the surroundings, and as well as matter also will be exchanged with surroundings. Such type of systems are known as open systems, right? So here same hot water we have to consider hot water, but this time that hot water will be in a closed vessel. What about that closed vessel, right? In closed vessel, is there possibility of exchange of heat energy to the surroundings? Yes. What about matter? No matter, because it is a closed one. If it will be vaporized and touches to the top of the vessel, as the temperature will be decreases and it will condense to form water. Therefore the quantity doesn't change, right? So therefore what are the conditions we have to consider? Delta Q will be changed, therefore this is not equals to 0. Then delta M is equals to 0, because initial and final will be same. Initial and final will be same. Therefore delta M is equals to 0. So what we have to define the closed system means the system in which heat energy only exchange with its surroundings but not matter. Such type of systems are known as what? Closed systems, right? So coming to the part of third one, isolated system. What is meant by isolated system? Both heat energy and matter does not exchange with its surroundings, right? Example of isolated thermos flask, right? So just consider a thermos flask, right? In that thermos flask a cup of tea is present, right, which is made up of with isolated phenomenon, right? So this is a thermos flask, a cup of tea is present, right, in which neither heat energy nor matter will exchange with its surroundings, right? If there is a change of heat energy means this is not a perfect 100% isolated system. We have to purchase outside the thermos flask, even it will be work up to certain period of time only, right? So just today only purchase and so keep 2 cup of coffee or tea in thermos flask and kept aside, right? At the time of our CSR examination, just you have to check whether same heat will be there or not. If there is no same heat means that is not a perfect isolated system. That is isolated but some percentage only it will be works, right? Up to certain level only. Behind that it won't work. No 100% isolated systems are available in the universe, right? If it is available, we have to store so many things, right? So no 100% isolated systems are available in the universe. So little bit so drawback will be there, right? So because we made with isolated phenomenon only, with the help of surroundings sometimes, so that property may be destroyed. Therefore at that particular place it won't works properly, right? So that's why. So these are the 3 type of systems are there, right? ISO means you have to remember. So many times we used this terminology. ISO means what? Constant, right? ISO means constant, right? You people are coming regularly to the class. ISO boys means same strength coming regularly, constant strength, no increasing, no decreasing, like that. ISO terminology means what? Constant. So many properties we have to apply ISO term, right? ISO means here both are constant or not. Heat is constant and as well as matter also constant. Whenever the property is kept constant, that can be denoted with ISO or isolated, right? These are the 3 types. Just to put first one open system, just write the definition and write these examples and conditions. Then after that closed system, isolated system. Just put heading open system, right? Yes. Any doubt? Based on boundary surface, heat and matter, right? So these are the 3 terms. One is the boundary surface, because here there is no closed boundary surface. Here closed will be there, here isolated will be there, right? It won't allow heat energy. So therefore this is the word which wall? Diathermic. Won't allow heat energy. Adiabatic. These 2 are what? Diathermic walls. These 2 are allowing heat energy to transfer to the surroundings. Therefore these 2 are diathermic walls. This is the adiabatic wall. That's why boundary surface is also different, right? So based on the boundary surface, comma, heat and matter, systems are, first put heading open system and write that under open system. The system in which both heat energy and matter, the system in which both heat energy and matter will exchange with its surroundings. Both heat energy and matter will exchange with its surroundings, right? Example, hot water in a open beaker. Example, hot water in a open beaker. Draw the diagram and write the conditions. Draw the diagram and write conditions. Remember one thing, whatever is the concept is there, that we have to explain with the help of diagram or with the help of equation, not in a sentences form. If we have to remember in a sentences form, it will be forgettable easily. With the help of diagram, it will be remember for long period of time, right? So try to understand the subject with the help of equations, right, or diagrams or graphs, like that, right? Okay. Example, hot water in a open beaker, and conditions will be delta Q is not equals 0, delta M is not equals 0. So delta means nothing but change, right? What is meant by delta? Delta will be change. So this is only I have explained again here. So just you have to write one only, or else you have to write both, right? Then put heading closed system. Closed system, right? Write the definition under closed system, right? The system in which only heat energy will exchange with its surroundings, but not matter. Right? Example, hot water in a closed vessel. Simple. So take hot water in your bottle and come to the class, right? After a few hours, same water will be there, but heat will be changes, right? So that is, right, the examples and conditions. Example and conditions. Right, next, isolated system heading. Right. The system in which neither heat energy nor matter. Do you know about either or and neither nor? Neither nor means won't allow, right? Either or means that will be allow. Here in this case, neither nor, right? Neither heat energy nor matter will exchange with its surroundings. Example, a cup of tea in a thermos flask. Closed vessel. This is the open vessel. Closed vessel and thermos flask. Isolated, or else that wall will be adiabatic wall. In case of this thermos flask, even we have to write adiabatic wall. Where we have to utilize this adiabatic wall, adiabatic condition? Joule-Thomson experiment will be there. At that time, particularly, we have to use this condition of isolated system. So these are the systems, right? So now tell me, delta Q is not equals to 0, delta M is equals 0. Is this system is available? Acha, this one only, na? Right. Okay. Next, delta Q is equals 0, delta M is not equals 0. Delta Q 0 means constant. There is no change of heat. Delta M not equals 0 means there is a change of matter. Without heat change, is there possibility of matter will change? Whenever heat will be changed, there is a change in matter, right? So even in open system, matter will be changed without exchanging heat energy? No, it won't happen, right? So therefore it is not applicable, right? So whenever heat will be changes with respect to the matter will allows, whether it will be changed or not, that is depending on the systems, right? Either open or closed or isolated system. These are the three types of systems, right? Okay. So we know that the definition of system and the various type of the systems, right? Then put heading thermodynamic state. Right. So what is meant by system? Any specified portion which is under our observation. What are those observations we have to consider for that system, right? So I have selected this is the portion, this is the system, right? So this is the system is present at temperature is T, pressure is P, volume is V, and composition is N. Where we are considering that system? We are considering that system on earth, or we are considering that system on moon, right? So means what are the conditions there? What is the temperature, what is the pressure, what is the volume, and what is the composition, right? So means we have to know about these four parameters. Not only these four, even some other will be there. The major properties will be temperature, pressure, volume, and composition, right? So for example, I am considering one system, right? So that is at what is the time right now? 7 o'clock, right? 7 p.m. 7 p.m. I am considering one system. So what was that system? Means temperature will be our room temperature, that is 27 degrees centigrade. Pressure will be 1 atmosphere, and volume will be 1 liter, right? So this is the particulars of the system I have considered at 7 p.m. right? After our completion of the class, so maybe consider at 9 p.m. right? Means don't think the class up to 9, right? So that will be 9 p.m. Is there change of temperature of this room? No. Is this change of pressure? No. Is this change of volume? Volume will be changed or not? No, right? So therefore there is no change of system properties with respect to time. Therefore that system is said to be in thermodynamic state. That means the properties of the system does not change with time. Here time will be changed, but all the properties will be same. Time will be changed, all the properties will be same, right? So then, so the same. So tomorrow 6 o'clock we have to see. That is what next day. Unfortunately, a big rain was there, right? So means temperature will be changes, right? Suddenly rain will be there means room temperature will be change, right? So therefore the temperature will be little bit decreases, that is 24 degrees centigrade. The pressure will be 1 atmosphere, right? So then volume also will be same 1 liter. Is there change in one property? Right. So whenever the property is changes with respect to time, so therefore this is known as what? Thermodynamic process. This is the word thermodynamic state. Any property do not change with time, that is known as thermodynamic state, right? If that particular property will be changed with respect to time, that is called thermodynamic process, right? Thermodynamic process. So clearly understand what is meant by thermodynamic state. So means what are the properties we have to consider for the system that always constant with respect to time. If even time will be changed, all those properties what we have considered for that system, that becomes remains constant. Therefore that system is said to be in thermodynamic state, right? So if one of the property can change, there is a change means there is a process. There is a change means there is a process. Therefore that is called thermodynamic process, right? Okay, so write down. When a system is said to be, when a system is said to be in thermodynamic state, in thermodynamic state, and whose properties do not change with time. Whose properties do not change with time, right? Will stop. Right. The properties of system, next point, the properties of system considered as temperature, pressure, volume and composition. These are the basic properties of the system, right? Temperature, pressure, volume and composition, right? So just write this example. What you have to do means, first take 7 pm, 9 pm, then next day 6 pm here. So this will be change means we have to write. So this is the thermodynamic state. If changes will be there, thermodynamic process, right? Property here, property no change, even you have to write the property no change. That means thermodynamic state. Thermodynamic property means one of property will change. Not only the temperature, any one of the property will be changed. So therefore that is involved in some process, right? So therefore that is called thermodynamic process, right? So thermodynamic state and thermodynamic process. So based on these conditions of thermodynamic state, how many type of processes will be there, right? So there are various type of processes will be there, right? So because here whenever the temperature will be changed, pressure is what? Constant. Therefore with respect to that pressure we have to denote this one process. In other cases temperature is constant, pressure will be changed. With respect to temperature we have to denote that one process. In other cases pressure and temperature will be varying, volume is kept constant. That is with one process. Like that there are various type of thermodynamic processes will be there, right? So just put heading thermodynamic process. Right. Thermodynamic process. That is a thermodynamic state, right? So I want to write thermodynamics every time like TD, but you people won't write like this. You have to write completely thermodynamics, right? So thermodynamic process. Right. There are various types of, right on. There are various types of thermodynamic process. There are various types of thermodynamic process which includes first one, isothermal process, which includes first one, isothermal process. What is meant by iso? Constant. Thermal means temperature. Temperature remains constant. Whatever is the system, one system is converted to the other system. During that conversion, the temperature remains constant. Therefore, such process is known as isothermal process. So, this is the system A. Then we have to consider one more system, that is the system B, right? So the system A is converted to system B, right? So what are the properties of the system A? System A, temperature is T1, pressure is P1, volume is V1, and composition is N1, right? So this will be converted to the another system, that is system B, means temperature is T1, pressure is P2, volume is V2, and composition is N2. Which one is constant? Temperature is remains constant during this process. Temperature remains constant, right? So such process is known as what? Isothermal process, right? Write down the process at which temperature remains constant. The process at which temperature remains constant, right? So when temperature remains constant, what are the conditions? That is T is constant. T is constant mean, what about dt? Change in temperature. dt means change in temperature. This is also we have to written as delta T, right? dt and delta T means change in temperature. What about that change? Zero only. Here T1 means, for example, the system is present at 25 degrees centigrade. So this is system B also at 25 degrees centigrade only, because there is no change of temperature. Temperature remains constant. 25 minus 25, that becomes 0. Therefore dt or delta T is equals to 0. These are the conditions of isothermal process, right? These are very important, because many cases just we have to apply the condition is isothermal. We have to say the process becomes isothermal process, means immediately dt or delta T will be 0. That we have keep it in mind. Or sometimes T is constant also we have to utilize. These are the two conditions we have to utilize. Just draw the diagram and write conditions again, right? Or else you have to draw the diagram. Because by seeing the diagram, so all the properties will be changes except temperature. Temperature remains constant. Therefore such process is what? Isothermal process, right? Like that. Second one will be isobaric process. Right. Isobaric process. Which parameter is kept constant? Pressure. Blood pressure we have to remember. Blood pressure, right? Or else BP. BP will rise sometimes, right? So therefore BP. Baric process means pressure is kept constant. So I think no need to give diagrams every times, because just only that parameter will be constant. System A, system B, right? Pressure remains constant. So the system will be T1, P1, V1, N1, T2, P1, N2, V2, right? N2, V2, right? Except pressure, remaining all will be changes, right? So that now that is only we have discussed with respect to time, right? So one will be changing, other all are constants. So with respect to that, which one is constant? Based on that we have to say the condition. That is the process, right? Which one is kept constant? Based on that we have to say that process, right? Okay, so this is what are the conditions? Pressure remains constant, that is change in pressure dP or delta P is equals to 0. This we have to remember. Isobaric process means dP is 0. Isobaric process means dP is 0. Then third one, isochoric process. Isochoric process, right? Temperature is over, pressure is over. What about remaining? volume is kept constant, right? So remember, Sir C.V. Raman. Remember C.V. Raman, who invented what? Scattering of light, Raman effect, right? He got Nobel Prize for that experiment, Raman effect. Remember C.V., right? So C.V., right? Choric process means volume constant, right? Just volume remains constant. Volume remains constant. That is, change in volume or dV or delta V is equals to 0. Right? How many processes? One is isothermal, isobaric, isochoric process. Right? So then the next process will be fourth one. Adiabatic process. The next process will be adiabatic process. Which one is kept constant? You are saying composition? Because 3 are completed, remaining only one composition. Already we have discussed adiabatic condition. What was? Heat only. Heat remains constant. The system A is converted to system B, right? Right. System A is converted to system B. Throughout this conversion, Q is what? Constant. Remaining all temperature will be, right? T1, next P1, V1, N1, right? So then temperature will be changed, P2 will be changed, V1 will be changed, N2 will be changed, right? V2. So means only heat energy remains constant. Q is constant. Q is constant, right? So and also here temperature also we have to write T1 because it has relation with temperature. Heat is a form of energy that is due to temperature difference only. Okay, no need. Temperature difference also we have to take, right? So that is due to temperature difference only. Whenever temperature difference will be there, we will get heat energy. That heat energy is always constant. Whenever heat energy is constant, what about dQ? Delta Q is equals to 0. This is the adiabatic condition, right? So then the fifth one will be cyclic process will be there. Fifth one will be cyclic process, right? So here so many systems are there. The system A is converted to system B. System B is converted to system C. Again system C is converted to system A, right? So means all the conversions of systems are kept in a cyclic manner, right? So system A to B, B to C, again C to A. This will be in cyclic manner. Whenever this is cyclic manner, right, all the thermodynamic properties change becomes 0, right? So therefore the conditions of cyclic process will be, write that delta H is equals to 0. What is meant by delta H? Enthalpy. H for enthalpy. Delta E becomes 0. Next, delta S becomes 0. Delta G becomes 0. And delta A becomes 0. Write a statement there. The change of thermodynamic property. The change of thermodynamic property. The change of thermodynamic property becomes 0 when the process is carried out in cyclic manner. becomes 0 when the process is carried out in cyclic manner. Right. So that is dH, delta H, delta E, delta S, delta G, delta A all will be 0. Even we have to represent the symbol of cyclic process. Right. Do you know the symbol of cyclic process? Right. Crossed integral we have to show. Right. That is integral with circle. Circle integral, that becomes closed process. Then change of enthalpy, closed integral of dE, internal energy, closed integral of ds, closed integral of dg, closed integral of dA, that becomes 0. So this is the symbol of closed integral will indicate cyclic process. This will indicate cyclic process. Right. So sometimes the closed integral symbol also we have to utilize for the cyclic process. So we have to remember all the thermodynamic properties change becomes 0. So when the process is carried out in cyclic manner. Right. So how many processes are there? 5 will be there. First one will be isothermal. Which parameter constant? Temperature. Isobaric means pressure. Adiabatic, heat constant. Cyclic process, all thermodynamic properties. Right. What about isochoric? Volume is kept constant. These are the processes we have to discuss it in thermodynamics. So one is the system, first one. Then 3 type of systems: thermodynamic state and thermodynamic process. Right. So then move on to the next topic. These are all basics only. Even we have discussed numericals based on these basic concepts also. Right, after completion of all the basics. Right. Write down. Intensive and extensive property. Intensive and extensive. Property. Intensive property and extensive property. What are the thermodynamic properties? Excuse me. Right. Thermodynamic properties. Thermodynamic state consisting, what are the properties? Pressure, volume, temperature, composition and some other. Those properties are dependent on amount of substance present in the system or not. Whatever is the property, whether it is depends on weight of the substance or amount of the substance which is present in the system. Whether it is depends or independent, based on that there are 2 type of properties will be there. One is what? Intensive and extensive. Right. So first put heading intensive property. Intensive property. The property in which, write down, the property in which the substance which is independent, present in the system. The substance which is independent on weight, present in the system, which is independent on weight present in the system, right? Is called intensive. Just forget about that. Just remember that independent. Intensive property means independent. What is the independent? Weight of substance which is present in what? System, right? Just write on this. I means intensive property, that is independent on weight of substance that is present in the system. Alright, tell me the examples. Examples of intensive property. Any property that is applicable to the system and also independent on weight, right? Temperature is good. Temperature, for example, 27 degrees centigrade. It has any amount of weight? 27 degrees centigrade has some weight? No. Then pressure. Pressure has some weight? No. 1 atmospheric pressure. No weight is there. Next. Specific heat capacity, right? Specific heat capacity. Specific heat capacity. Next. Refractive index. Next. Refractive index. Next. Molar heat capacity. Molar heat capacity, right? Next. Electromotive force, right? EMF. Next. pH, pOH. Then specific heat capacity. Then viscosity, surface tension, these all are what? Independent on weight of the substance present in the system, right? So then what about number of moles? Depends on weight. What about concentration? Concentration. Okay, right. So write this example, all this. Temperature, pressure, specific heat capacity, refractive index, molar heat capacity, EMF, pH, pOH, then viscosity, surface tension, etc. These all are independent on weight of the substance present in the system. Then what are the dependent? Based on that we are able to get extensive properties, right? Extensive right. Here it is, I means independent, intensive means independent, right? So therefore extensive means what? Dependent. Dependent on weight of substance which is present in the system. Write the definition. The property or function, the property or function which is depends on the property or function which is depends on the weight of the substance. The property or function which is depends on the weight of the substance present in the system. Weight of the substance present in the system, right? So that is extensive property. Examples. EXP, how to write extensive property, right? Tell examples. Volume, right? Mass also. Mass is what? Extensive. Next, volume, Next, number of moles. Number of moles extensive or intensive? Weight by gram molecular weight. Intensive or extensive? Sure? Extensive? Okay. Take one example here only. 1 mole of water consisting how many grams? 18 grams of substance. Right? 2 moles of water. How many grams? Right. Number of moles already we discussed na. N is equals to weight by molecular weight. Number of moles is 2. Molecular weight is 18. 2 into 18. 36. That is the weight. Right. As the number of moles will be dependent on weight or not. Right. This is 36 grams. 2 moles means 36 grams. Therefore, this is weight dependent. Weight dependent. Therefore, extensive property. Number of moles will be what? Extensive property. Right. Mass, volume, number of moles. Right. Next, internal energy, enthalpy, heat capacity, entropy, Gibbs free energy, Helmholtz energy function. These all are extensive properties. Okay. Intensive and extensive. Right. Right. Right question. Density is intensive or extensive property? Density is intensive or extensive property? Right. Intensive or extensive? Extensive. What about definition? Density is equals to mass by volume. What about mass? Extensive property. What about volume? Extensive. The ratio of extensive properties becomes intensive. Therefore, density is what? Intensive property. Isn't it or not? No? Density is intensive or extensive? Intensive. Right. What about water density? Water density 1.00 grams per ml. It has some weight. Density has some weight. That is the value only, na? 1.00. Density of water is 1.00 grams per ml. So that independent on weight. Therefore, intensive property. Right. So this may be explained with the help of that. Right. With the help of an example, we'll see. Right. Some X property is there and Y property is there. Right. X and Y. Right. X is a extensive property. This is also extensive property. Right. Extensive property and extensive property. Right. Consider number of moles. Right. So for 1 mole, X value is 2, Y value is 3. 1 mole of substance is there. extensive property is 2 and extensive property of y is 3, right? So I can change mole to 2 moles. Extensive properties depends on moles or not? Moles is extensive property or not? Extensive, that is depends on weight. So therefore for 1 mole 2 means, what is the value of 2 moles? 2 moles means 4, right? So therefore what about 3 moles? 6, right? So therefore 2x into y we have to do and x by y we have to do. X into y means extensive property into extensive property, right? X by y means extensive property by extensive property, right? Extensive by extensive only, right? We'll see. X into y, 2 into 3 means 6. 4 into 6 means how much? 24, right? X into y, same value or different values we are getting? Different values, right? We are able to see x by y, right? X by y. X by y means 2 by 3. Here in this case 4 by 6. 4 by 6 means what? 2 by 3. Here we are getting the result of ratio of extensive properties. This ratio of extensive properties are same means these are independent on number of moles. Mole is a weight of the substance, right? Therefore this x by y, two extensive properties ratio becomes what? Intensive property, right? X is a extensive property, y is also extensive property. That ratio will be same we are getting means that is independent on this, right? Whenever this ratio is independent on this, therefore that becomes considered as intensive property, right? Therefore intensive property is equals to the ratio of extensive property by extensive property, right? Now tell me the concentration. What about concentration? Next question. Concentration is intensive property or extensive property? What is the definition of concentration? Number of moles by volume. C is equals to N by V, right? Why doubtful? Right. What about N? Number of moles means which property? Extensive property. What about volume? Extensive property. Therefore that ratio becomes intensive property. Concentration is what? Intensive property, right? Extensive properties and intensive properties, right? So this kind of example we have to consider for intensive property. What we are getting we'll see, right? X value, y value, x into y value, x by y value. In this case x is equals to what? Intensive property. Y is what? Intensive property. Here what we have considered? X means extensive property, y means extensive property. But here x means intensive property, y also intensive property. Consider number of moles. For 1 mole, same values we have to consider. What is the x value? 2. What is the y? 3. What is the product x into y? 6. What about x by y? 2 by 3. Right. For 2 moles, what about x value? For 2 moles, what about X value? X is what? Intensive. Intensive is depends on weight or independent? Independent. Whatever is the number of moles, that value is always 2 only. Independent. If it is dependent, as it will change, this value also will be changed. But this is independent only. We are discussing about intensive property means independent. So whatever is the number of moles, that is independent on that. Therefore, what is the value? 3. Therefore, what is X into Y? 6. What about X by Y? 2. Therefore, intensive property is equals to intensive property by intensive property. The ratio of two intensive properties also becomes intensive property, right? Either extensive properties ratio or intensive properties ratio. That always intensive property only, right? Just to keep it in mind these two terms. So we are able to get even some other words based on this. We are able to solve easily, right? Right, make a note, write note, NOT, note. Extensive properties are additives or additive property. Extensive property is additive property, and intensive properties are multiplicative properties. Right? Extensive properties are additive and intensive properties are multiplicative. Only two will be there, right? One will be depends on weight, other will be independent on weight, right? Depends on weight means extensive property. Independent on weight means intensive property, right? So note to second note, that is too important, right? That is the first one note, and the second one, right? Write down. Any property is expressed in per mole or per gram or per unit or per volume, etc., becomes intensive property. Right? Whatever it we may consider, right? That will be expressed per gram or per volume, per unit or per mole. That is independent on weight, right? Particularly per 1 unit, right? So for example, specific conductance will be there, K value. Specific conductance. Like conductivity, specific conductance, molar and equivalence conductance will be there. Specific conductance is particularly for 1 centimeter square area, right? So means any property that should be expressed with specific. That's why specific heat capacity is intensive property. Specific heat capacity is extensive property. Specific heat capacity is intensive property. So that will be specific either per 1 mole or 1 gram or 1 unit, whatever it, right? Heat capacity is extensive property that will be expressed per unit, that becomes intensive property. So whatever is the property is expressed in terms of this, that becomes intensive property, right? Example, specific heat capacity, right? Specific heat capacity. Next, molar heat capacity. This molar and specific means per 1 gram. So molar means per 1 mole. Heat capacity per 1 mole, heat capacity per 1 gram, that is always independent on weight of the substance, therefore that becomes intensive property, right? So this is about extensive and intensive properties, right? So then one more concept is there, so we will discuss that and put heading state functions and path functions. State functions and path functions. State functions and path functions. Intensive, extensive will be there. Even some other terminology we able to get, just remember only, don't write. Extrinsic and intrinsic. Extrinsic and intrinsic, little bit pronunciation was different. Extensive, intensive, that will be discussed in thermodynamics. This extrinsic and intrinsic terminology is applicable for semiconductors, so that is in solid state chemistry. N-type semiconductors, P-type semiconductors, extrinsic and intrinsic semiconductors, right? So this is extensive and intensive. Fortunately we able to see whether it is extrinsic or extensive, right? So we have to focus on the terminology also, right? Extrinsic and intrinsic, this is used in semiconductor concept, that is in solid state chemistry, right? So state functions and path functions, right? What are the state functions and what are the path functions? How we are going to describe the thermodynamic concepts with the help of these, right? Right, state functions and path functions. Let's see, with the help of diagram we have to understand, right? System A is there, the next one will be system B is there. A and B are same systems or different? Different, that's why different diagrams I have to use, right? So both are different systems, system A and system B, right? System A is present at temperature is T1, right? Temperature is T1, pressure is V1, volume is V1 and composition is N1, right? So when system B is present at temperature is T2, volume is V2, pressure is P2 and composition is N2. What about that process? Adiabatic, because these all are changing, right? So whenever these all are changes, Q is constant, that is a condition we have to apply, adiabatic condition, right? Okay, so that is won't give any information in this case, right? So system A and system B is there, right? System A is converted to system B through a pathway 1. There is a one procedure is there to convert system A to system B, okay? Then one more also will be there. So that system A is converted to system B, that is pathway 2, right? So one more also will be there, that system A is converted to system B through pathway 3. One more also there, that system A is converted to system B through pathway number 4. Means there are many number of pathways are there to convert one system to another system. Here we are representing how many pathways? 4, right? So what are these T1, P1, V1 and N1? These all are initial states of the system. Thermodynamic state, this is, right? So these are the initial states. This will be changes, means these are the final states of the system, right? So these are the what? Final states, right? Any property we have to consider any property, right? Any property that is dependent on initial and final states and independent on pathways. Understand? Any property that is depends on initial and final, right? And independent on pathways. Such properties or functions are known as what? State functions. Understand? Depends on initial and final states, that are state functions. What are the state functions? Means all thermodynamic properties, all TD properties, right? What about all TD properties? Internal energy, enthalpy, entropy, Gibbs free energy, Helmholtz energy function. These all are what? State functions. These all are state function, depends on initial and final state. Initial and final state and independent on pathways. Therefore these all are state functions. Some other functions will be there. Path pro means the properties which are depends on pathways and independent on initial and final states, right? Depends on pathways and independent on initial and final states. Such properties are known as what? Path functions or path properties. What are the examples of path properties or functions? Here all thermodynamic properties. Here what? I already told in this during that pathway how it will be converted. System 1 is converted to system A is converted to B. What is the changes? Heat energy changes. Remaining all are changes, means heat energy remains what? Constant. Heat energy is constant during this pathway. For example, system A is converted to system B by liberation of heat energy, right? That will be there. In another pathway is there. During this also system A is converted to system B, but this time little bit excess amount of heat is evolved. Means that heat energy is depends on what? Pathways, right? Whether during this pathway or during this pathway, simply we go with distance. Here more distance is there, more energy is released. Less distance is there, less energy is released. Means energy is what? Depends on pathways. So therefore what is the path property? That is the heat. Whenever heat will be changes, that is also depends on one more property. That is what? What? Work. Right? Work also. Here distance will be small, means small work will be there. Here distance will be more, means more work is there. Means that is depends on pathway or not. Work is depends on pathway or not. Irrespective of the initial and final states. Just that is depends on the pathway. Right? Just you have to move walk from here to Shanti Theatre, or you have to walk from here to RTC Crossroad, where the work done will be different or not? This is the one pathway, that is another pathway, right? So more work you have to do to walk from here to long distance. Means the work is depends on what? Pathways. State functions and path functions. The relation between these two is called thermodynamics. So what is our main topic means? Thermodynamics, that we are going to give the relationship between state functions and path functions. If heat will be transferred, how much work will be done, right? So then when some work will be done, what is the change of internal energy? What is the change of entropy? What is the change of Gibbs free energy, right? If this will be changes, right, how the process becomes either reversible process, irreversible process, or spontaneous process, non-spontaneous process. So these kinds we are going to explain with the help of these properties, right? So this is the importance of thermodynamics of state functions and path functions, right? So just note down the diagram, then we'll write the sentences. So have you understand this one? Any property you have to take, right? Thermodynamic properties means these are thermodynamic properties. These all depends on what? Initial and final states only, independent on pathways. But only these two are depends on pathways. Then these two are depends on pathways. These are independent on initial and final state. How these are correlated with each other? So that is called thermodynamics. Right? We are going to give the relationship between the state functions and path functions is called thermodynamics. Right? With the help of this only we able to get the information what we have discussed in importance of thermodynamics, that all we are getting with the help of relations between these. Okay? Right. Just write down. The property which is depends on initial and final states of the system. Initial and final states of the system. Initial and final states of the system. In bracket, just you have to write system A to system B. Means conversions of systems. Write in bracket. Initial and final states of the system, and independent on pathways. Called state functions. Right. Example, all thermodynamic properties. If you want, you have to write all these properties. Already written, no need, right? Okay. Next, path functions. The property or function which depends on pathways and independent on initial and final states of the system. Example, heat and work. right? So that will be concluded with even some example also, right? Example, see, integral of initial states and final state. Even we don't know what is the initial state, what is the final state, right? For example, in terms of temperature, T1 to T2, whatever is the temperatures, initial and final states, right? So during this initial and final states, the change of entropy is equals to, the change of entropy is equals to, right? So this will be initial state to some x value, that is the ds, where we are doing, this is the one of the pathway, right? So initial state to some x, right, plus integral of that x to final state into ds. So means here we are representing a pathway, right? So pathway is what? Through x, whatever is the value, right? So here we are getting some value, right? So then in second case, initial state and final state of ds is equals to integral of initial state of ds plus integral of final state of ds. Now the pathway will be different, here a, here x, right? Here pathways are different or same? Different. Here what is the pathway? Initial state to x, then x to final state. Here what about pathway? Initial state to a to final state, right? In both these, the values will be, the obtained values will be same. Therefore it is independent on pathway. The property is the what? Function, that is entropy. Entropy is independent on pathways. Whatever is the pathway we have to choose, right? That depends on what is the initial and what is the final only, irrespective of the pathways, right? Here pathway is x and here pathway is a. Whatever is the pathway, that the final values will be same. Therefore ds is what? ds is what? State function. Means entropy is a state function. Therefore s is a state function, or ds is a state function, right? Second category, right? Integral of initial state to final state of dw. What is meant by w? W is the work done, right? So therefore we have to consider that is the initial state to y, then dw plus y state to final state of dw, right? So then again initial state of is equals to initial state of some b of dw plus integral of b to final state of dw. In this case we are getting same value or different value? Different value. Therefore that is depends on what? Pathways. That's why work is a path function, right? So therefore here we are getting a different value, right? Different value. Therefore w is a what? Path function, right? W is a path function. Even we have to explain with the help of integration part also. Whether pathway we have to change, right? Pathway means simple only. Initial and final state means temperatures will be there. 0 to 100 degrees will be there, right? For example, initial will be 0. Initial will be 0. Final will be 100. Temperatures 0 degrees and 100 degrees. Here initial 0 to 10 degrees, then 10 to 100 degrees, okay? Initial 0 to 50 degrees, then 50 to 100 degrees. Here pathway was different. This function is depends on initial and final only. That's why we are getting same answer, same value, right? If pathway is different, W means we are getting different value, means depends on pathways, right? So therefore these are the state functions and path functions. The relation between these state functions and path functions we are going to discuss, right? Even shall we discuss one more topic? Right. So this is the method is known as Euler's method. Just mention here, this is the word Euler method. What about the method? That is Euler method. With the help of Euler method, so we have to explain state functions and path functions, right? So this integral part we have to utilize, that is based on the Euler's method only, right? Okay. So somehow thermodynamic properties are exact differentials, right? So what is the concept of exact differentials? Then we have to go with in detailed definitions of all those. What is the heat? What is the work? What is the internal energy? What is the enthalpy? Then like that we have to move, followed by zeroth law of thermodynamics and first law of thermodynamics, right? So slowly we move on to main topic, right? Okay, so that will be discussed in the next class.